Today we're going to talk about how we use integration to find an average value of a function on an interval. And when I say average value, important to note that we're talking about an average y value of a function. So there is something called the mean value theorem for integrals. Now don't get confused, just take a minute and let's go through it. If I have an integral from a to b of f of x dx, it is equivalent to f of c times b minus a, okay? This is true if f is continuous. There will be a number c such that this is true. I want to explain where this comes from. So let's start with a pretty easy function, and let's let that function be a quadratic function, okay? And let's say we want to find, here's our interval a, let's mark that, a and b, and what I want to know is what is the average value of this function, the y value here, on this interval from a to b, okay? So the geometric interpretation says that we're going to have a number c in the middle of a and b such that the rectangle with base a, b, and height f of c has the same area as the region under the graph. Now stay with me for a second. So if I were to say that this is going to be the base of some rectangle, and there is a spot, we'll call that point C, such that if I go to the y value at that spot and I make a rectangle, so it's as wide as a to b and as tall as f of c, because this point right here is c f of c. So the height of this function is f of c, and the base of this function will be b minus a for this rectangle. Okay. Now we're going to call this the perfect rectangle. When I say a perfect rectangle, what I mean is a rectangle whose area is exactly equal to the area of the region under the graph. So I can tell here, if I were to find the area of this rectangle right here, if I have set this up at the perfect spot, where here is a, here is b, the height of this thing is f of c, and b minus a. This rectangle should have the same area. It should have the same area as the region under the curve, okay? So how do we find the area of a rectangle? We find the area of a rectangle by multiplying base times height. So f of c times b minus a. Well, how do we find the area under the curve? In this case, the area under our parabola, well, that's going to be the integral from a to b under my function. And now I'm saying that these two things are equal to each other, okay? So I am saying that this area and this area are equal. So here is my area under the curve. And here is my area of the rectangle. Now, important to note that this spot, f of c right here, is actually pretty significant. This f of c is your average value of your function f. And when I say an average value, we typically are saying y value, okay? Now, if I took this function right here and I solve it for f of c, I can find out that f of c is equal to the integral, actually I missed something, 1 over b minus a integral a to b of f of x dx. So all I've done is solve for f of c, okay? Now this f of c we call the average value of this function, okay? So we've just discovered our average value formula. Let's apply it. Let's make it actually make some sense. So let's start with the function 1 plus x squared, and let's actually make a quick graph of this function, 1 plus x squared. So I'm going to kind of skip to c. Remember that the function 1 plus x squared is a parabola moved up 1 unit. And we are particularly interested in the interval from -1 to 2.
Good morning, Rangers. Please rise for the Pledge of Allegiance to the flag. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God.
I'm going to graph while they're doing announcements.
With liberty and justice for all. And now for the Pledge of Allegiance to Texas. Honor the Texas flag. I pledge allegiance to thee, Texas, one state, under God, one and indivisible. Please be seated for a moment of thoughtful reflection.
Okay, so I've graphed my graph, and we're particularly interested in the interval from -1 to 2 right here, okay? Now, let's use our formula. Our formula says that the average value is going to be equal to 1 over b minus a integral from a to b of f of x dx. So let's apply that. If I want to find the average value of this function.
Thank you. Hey Rangers, great to see everybody today. Hey, tune in to today's newscast to find out how you can get involved in this year's Blue Santa fundraiser. Next on BRTV News, hey, Miss Rich High School, we are
Preparing students to be best for the world.
Go Rangers.
So I've set up my a value, my b value, and I've applied my function f of x in the formula. Please pay attention though that this is f of x. It's not f prime, so I'm literally putting that function right there. So I'm going to simplify this a little bit. We're going to get 1/3. I'm going to take my antiderivative and get x plus x cubed over 3. We're evaluating this from -1 to 2. I'm going to put my 1/3 all the way on the outside, and we're going to go 2 plus 2 cubed over 3 minus -1 plus -1 cubed over 3. Close my brackets. And then being a little bit careful with some parentheses here, I've got 1/3. I have 2 plus 8/3. Distributing in my negative sign, I'm going to get +1. -1 cubed will be -1, but multiplying that -1 in is going to make that a positive 1/3, which will give me 1/3. 2 and 1 is 3. 8/3 and 1/3 is 9/3, also known as 3. So we'll get 6 divided by 3, which is an average value of 2. Now what this means is, on this interval from here to here, the y value that it hits on average is 2. Part B of this says find c, which is the x value, such that the average value is equal to f of c. All they're asking you to do is, I'm going to take that y value of 2, and I'm going to set it equal to my function. I want to know what is the x value this is happening at. So I'm going to subtract 1. I'm going to get 1 is equal to x squared. I'm going to take the square root of both sides, and we get that x is either plus or minus 1. Well, I can see that. See here at -1, it has a y value of 2. Here at +1, it has a y value of 2. That tells me that is where I'm supposed to sketch my rectangle. So my rectangle goes from here to here. That rectangle has the same area under the curve as the function does on the interval from -1 to 2. So my rectangle and my function have the same area, okay? So we'll pick up here when we get back into class next time.